vulnerable to malwares, to different vulnerabilities, different threats that are that can happen online. So, with this in mind, if you look in the brief history, 2 years ago, there was this attack which was very publicized in the media when Lizard Squad took down Sony and Microsoft gaming networks. They had huge problems with that. Then Mirai botnet with massive DDoS attacks on IoT devices actually took 25% of the North American network down for some time. And only this year, WannaCry, we all remember WannaCry, hundreds of and thousands of PCs around the globe were infected. And as you can see, these attacks are not infecting one or maybe two PCs. They're on a large scale. They're affecting thousands of PCs at once. So we had this in mind when we started working on this project, and we created something which we call Sentinel Single Point Security Platform. Now, what this Sentinel technology actually is. When we started working on this, we had an idea how to secure all of your devices which are at home from a single point. And this is actually your gateway. So what we did, we placed all of the security that we need on this gateway, and we should protect all of the network, all of the devices which are connected to your home network. And we created next generation gateway, which actually has multi-layered security on top of it, which is responsible for securing all of these devices. Besides that, all of the services that are running on this gateway can be used as a lightweight packages separately and installed on different embedded devices as standalones. And the key features that we provide here, well, first, we were thinking of creating a device that we would use ourselves. So I would not like to have a device which at some point would collect data, my private data, send somewhere on some cloud and do with it whatever it does. I don't know what it does with it. So in order to avoid this, we have this premise, so to say, privacy first. So none of the data which is used, none of the private data of users never leaks the gateway. It's never sent somewhere. It stays on the gateway. It's actually never used outside of home network. Then we also created the device which is ISP ready. We had a support for some of the ISPs, mandatory parts, mandatory gateway, mandatory software, mandatory hardware, which we included into this solution as well to make it fully ISP ready. Besides that, we also have the provisioning protocols implemented to make it completely ISP ready as well. And the complete design is designed in a way to be future-proof, meaning that we can add or remove functionalities as we go along in the future. Now, when you think of it this way, all of the security placed at one point, securing your home network, why this hasn't been done before? Well, if you look, all of the legacy security that we have, security solutions are basically running on laptops, PCs, and other devices. They need a lot of computing power. They need a huge amount of RAMs to be efficient. And scaling those solutions to router preferences, router gateways, hardware can be challenging and maybe even not possible in a complete. So usually some compromises should be made, and the solution then would not be so effective. Then, if you look all of the gateways that we have now from in the market, they're usually locked. So you are not able to SSH on them, you're not able to access them to install third-party software or your own software. And this is why we use in this project OpenWrt, which is opened. We could use it to create our own environment which we needed, and also install our software on it to be fully functional. And at the end, the hardware that we have today usually is very low end. It has a small computing power compared to other devices that we have at home, and small amount of RAM. So this could be also very, very challenging for creating a full-scale solution like this one. And this is how the gateway that we created looks like. As you can see, it is quite aesthetically pleasing, very minimalistic, can fit in any home. and has these neutral colors. We have a prototype there on our booth outside, so you can go there and check it yourself to see how it actually looks and feels in real world. And what actually it has? Well, we can say that it is unified single box solution, meaning that it has a support for the internet, IPv6, IPv4, complete stack with all the necessary applications that are needed for around this system. Then multimedia support, IPTV for example. It can be used as IoT hub, and connect your IoT devices as well. As I said before, ISP's mandatory requirements, telephony has a full support for telephony on both hardware and software level, and everything is powered by OpenWrt. On top of that, we implemented Sentinel Services, which Tonimir would address in more details. And since it's powered by OpenWrt, we provide root access on the device so that it is possible to install third-party applications and services. And now Tonimir will tell you more about the services, Sentinel Services.
So, our security is focused on three main pillars, which we call Sentinel Services. First one is file validation, which checks for malware in traffic that is crossing the gateway. Second one is parental control, and third one is integrating with other telecoms and integrating our solution into telecoms. Each of these services is a standalone binary that can run on any type of Linux-compatible hardware, OpenWrt, LEDE, or whatever else anybody is using, but we can use it in conjunction or separately. Our 6 security pillars are concentrated in, first, the firewall, which is a standard network filtering firewall, which we augment with live threat intelligence from our lists that we use, which enables us to block any known URLs, any known IP addresses that are used in attacks or spreading malware. The second one is network analysis and machine learning, which is a behavior-based protection for all devices in the network. We do a network behavior profile, and then by identifying the normal network behavior, we can identify anomalous behavior and block any other attacks that are happening inside or going out of the network. We have our hash lookup, which is a method of detecting malware files that are closing the CPE, and we're augmenting that with our new algorithms that are based on hashing of identifying similar elements in malware or setting additional rules for detecting malware from known threat sources like Yara. If you want to detect malware, you need good data. Without good data, there is no point of doing it anyway. Our data source is reverse labs, which we have exclusive access for Toho on CPE based. It is used 8 out of 10 security companies. That means antivirus vendors, malware detection houses. It is extensively used in US government agencies during the world with large-scale financial clients, like commercial entities, financial institutions. And why is this important? If you look, for instance, Google's VirusTotal, they process about 1 million files of malware daily. Reversing Labs catalogs around 6 million files daily, and we have a 5 billion record reputation database. What this means is that we currently have more malware files than anybody else. And we are building that database, and we're building that analysis set 6 million files per day. This is the graph last year. 2 months ago, it was 6 million per day. Now it's even growing rapidly. So we're reaching a point where we have a large amount of malware per day. So what do? When you're surfing the net through your home gateway, the home gateway extracts files from the network streams, hashes them, checks the signature, and checks it against our file reputation database. That means we can detect any malware files in the traffic that is passing through normal HTTP, POP, IMAP protocols, or any other encrypted protocol like TLS. Currently, we have about 5 billion signatures with additional 6 million signatures of malware per day. What does that mean, for instance, in Bad Rabbit vulnerability, which came out 2 days ago, 1 day ago? From the initial 0-day outbreak of a malware file, we have honeypots, we have intentionally vulnerable systems, we have network devices that can detect malware on various large-scale Fortune 100 networks. And when we detect that malware, we have methods in place to do static analysis, dynamic analysis, and from the zero-day outbreak, we have under 12 minutes, we have a signature in place protecting all of our customers and all of our CP networks. Files are always validated on the gateway, which means no private data is exposed. We are never sending any files to the cloud. We only send a signature. Even a large amount of signature is being cached on the CPs, so we are sending only a small number of files. Not files, but the signature. That means ISP ready with fast and low latency in mind. We integrated this into our custom user interface that is running on the router. You can see a screenshot of it here, and you can see it live on our booth. Davor will talk more about that in his talk that is coming up in the afternoon, so check it out if you want to see how to integrate custom user interfaces into OpenWrt. We have encrypted traffic support, but that's happening on the customer's gateway with user consent. So we support IMAP, POP3, HTTPS protocol inspection. We can inspect those protocols too, and that data never leaves the network, and we're never sending any of it to the cloud. Additional pillar, we're looking at the network as a living organism. You can see a home network as a living organism. You can look at the whole telecom network as a living organism. What we're doing is we're detecting network behavior inside one of the CPs, so that never leaves your home network, and we can see which is your normal network behavior profile, and when that changes we can detect malicious network behavior profiles. If you correlate that across multiple households or across multiple, for instance, networks, you can detect global level incidents, global level threats that cannot be detected by normal methods. That is used to future-proof IoT devices in the network. For instance, in Mirai attack, you would see that a camera, which is a low network traffic device creating a large amount of traffic, we would be able to detect that. We also run, as an option, a parental control service, which is ISP ready, so integrates. It's intuitive for the users, since kids are using tablets, kids are using internet devices from a young age for 3 years, 4 years. We have predefined filtering templates and schedules, which you can use pretty easily. This is how it looks. So all management of devices is done in a user interface that's running on the router. It's intuitive to the users, it's nice to the eye, it's not straining or really technical, but enables even users that are less technical to configure their devices normally. Our last thing is Telecom Integration, where we enable provisioning of the services, IoT-controlled device firmware upgrades, customers alerts, everything that the telecom needs to integrate the CP. Our Telecom Integration service is called Miyagi, and we have a demo at our booth. So if you're interested in integrating a large number of CP devices, a large number of OpenWrt projects, check out Miyagi at our booth, and we can give you a demo, and you can see what we're doing here. We have from device control to monitoring, everything under control from one point. So to shorten this up, this is a turnkey solution available here today, runs as a service on in-field devices. It is hardware independent, it's vendor independent, it can run on anything that's Linux based. It's ISP ready with all of the network provisioning profiles you need, from TR069 to netconf young. And thank you very much for having us. If you have any questions, we'll be out there at our booth. You can check out our demos, and that's it. Thank you.